While the work on my main project huffs along, I thought I'd produce a post-mortem review of the first actual game I've made in Unity. Back in the day when I stepped on this path, my brain clung to the idea of making a 3D Sudoku, and I thought to myself, hey, that's small enough to finish and to get familiar with the engine. This project could be me putting a foot in the metaphorical door, proving to myself that yes, I've got what it takes to begin game deving for real. I present to you this video as a testament to that endeavor. Follow me as I show and explain what it feels like to make video games, from my point of view. One day, I was contemplating the depths of existence in this fleeting mockery of reality, and also playing Sudoku. I caught myself pondering on a rogue thought. Why did nobody make it in 3D? After solving some regular two-dimensional Sudoku, it gets stale, samey, and mundane. Why not take it to another dimension? Something to tickle your brain sponge with. Hell, why not make a four-dimensional Sudoku? My imagination ran wild with ideas and formulas. As it turns out, someone did make a 3D version already. There are 3D Sudoku games out there. I didn't try them. They seemed competent and functional. I did not find one that would appeal to me. They all look kinda technical, you know? Straight to the point. That is what you want from a Sudoku game interface. Clarity and simplicity, since you will be dealing with a whole lot of numbers. But I felt like I had a better idea. My source of inspiration was, I guess, Animal Crossing, with how smooth, touchy, tactile and relaxing everything is. Button presses, effects, sounds, and so on. It feels cozy. Myegh does that too. How about I make a Sudoku game like that? A cozy 3D Sudoku? I figured this would be a small enough project to prove to myself that I can make something in Unity that is, you know, finished. At least to some extent. They always say, dream big, start small. What is smaller than a Sudoku game? It shouldn't take more than, what, 2-4 weeks to finish? Don't tell my children I spent 3 months making a fucking Sudoku game, dear God! I mean, I am kind of telling everyone about it right now. Never mind. As it turns out, video games can take a shitload of time to make. Wow, what a surprise. Especially if you're making them alone. Everything in this project I did for the first time. My prior experiences did very little to prepare me. I did complete CodeMonkey's KitchenChaos tutorial, so at least I managed to avoid the majority of stupid mistakes I would have undoubtedly done otherwise, like making all my variables public. Ugh. I had 2 problems to solve. 1. How to make the game look how I want. 2. How to make the game work like a goddamn Sudoku should. The first I had to figure out all on my own because, well, I'm the idiot with the vision. I didn't have a lot of references to work with. As I've said, I was inspired by stuff like Animal Crossing and Myegh, with how pleasant they handle interface interactions. Oh yes, click away. The second one I could reconstruct from a bunch of tutorials. I had no interest in paving the way for some kind of groundbreaking, innovative approach to programming Sudoku games. Hell no. But how much can I get from a tutorial if I want to make a 3D Sudoku instead of a regular one? Shouldn't these systems be different? I don't know. Okay, let's start from the top then. There are 2 boards here, a 3D cube and a 2D spread of its planes. They are synchronized. You can solve the game completely within a 2-dimensional spread. You can do it with keyboard only, or mouse only, if you want. You have buttons for placing numbers, for placing hints, for undoing your work, for getting a hint, having the PC solve one cell for you. You can pause, change settings, by which I mean the sound levels, or change the color palette of the entire game. You can rotate the cube with the right mouse button to see where's what. You can shrink down the unsolved cells to see how the solved ones relate to each other. Down here is something interesting. These buttons are for changing the sorting method of the planes. Since we are working in 3D, it really doesn't matter if we swap the axes around. But get this, you might get a new perspective and be able to solve some cells easier by viewing it from another axis. In other words, these are all tools for making your precious little brain sponge understand the 3D cube better. Without them, Well, it's still doable, but harder, especially in these ADHD adult times. Any reason to play a digital Sudoku instead of a paper one is to have control over these small quality of life features. You may say this is cheating, to which I say, how dare you? I include an option to turn off some of the useful highlighting mechanics here, if you want to test your attention span. Speaking of visuals, I've got some words to say about those. 1 word, clarity. 2 words, visual clarity. 3 words, visual clarity rules. 4 words, there is this thing called UX, as in user experience. I understand the term as all the little things that make playing the game pleasant and nice. How do the buttons react to clicks? What sound do they make? What animations do UI elements have? How do you make the game feel good? What I had in mind was something with very limited palette, cubes with rounded corners, fonts that look hand-drawn, animate everything, use soft, pleasant sound effects, and yeah, all that stuff. This isn't really describable. You just see it in your mind's eye and then compare the result against it. Is this it? No. Is that it? Also no. Yeah, this is it. Yeah, that's my design document for you. Take it or leave it. Actually, no, don't take it. I may need it myself. At first, I thought to make cubes see-through, to make numbers visible in 3D. No matter how much I tried, it didn't look right. It looked like ass, actually. Instead, I opted for opaque cubes and added other ways to see numbers in 3 dimensions. Numbers are done in a Comic Sans, no, Comic Helvetic font, which is casual and playful, but a little bit more straight than Comic Sans. Numbers of the cells which relate to the selected cell wobble around. To do that, I've drawn every number and symbol by hand 4 times. Yep, all of these numbers aren't done with a font, they are just pictures. So if you wanted, you could replace them all with some other set of symbols, which I actually plan to do at some point. I experimented with coloring for a while as I tested my generators, just to make the board more readable, easier on the eyes. In the end, I ditched a multicolor approach in favor of this minimalist idea with 4 tones. I mix and match box and symbol colors tone to differentiate cell selections and highlights. Any given cell can be in several states depending on player interaction. Idle is the default state. Highlight when the cursor hovers over it. Selected when it was clicked and primed for input. There are also adjacent states, neighbors of the highlighted cell, neighbors of the selected cell, and cells containing the same value. Because the game works only with 4 colors, I can swap the color set out for another at runtime. Then I have a shitload of palettes here, and there can be even more. Same story with the animations. Highlighted cell wobbles, her neighbors and she herself get an outline. When your cursor enters a cell, this cell shakes slightly. When you select or unselect a cell, it pulsates. I wanted to make a selected cell shake like it's done something naughty, but I thought it looked stressful, the opposite of the feel I was going for. Everything follows the same set of rules. There is this underlying structure, consistency for every detail. Well, almost every detail. When cells shrink or unshrink, they do so according to a predetermined animation curve. When they shift places, they don't stay the same size. It doesn't look good when boxes clip into each other during a movement. So those cells, which move around, shrink and unshrink as they shift. This is also governed by an animation curve. Figuring out Unity's animation layer logic is not a trivial process. To cut down on the work, I've used prefabs to make these animations viable for both 3-dimensional boxes and 2-dimensional slabs. It broke down so much, I nearly broke down myself. It may all look trivial, simple, from the passenger view. Maybe it is. I really struggle to bring all of this into cohesion. But the result speaks for itself. What about sound? It's also a big part of the whole feel of the game thing. I don't really have a proper audio studio for recording my own sounds. So for this case, I went scrounging around the internet for what I need. Sites like Pixabay and Zapsplat were very handy. Some freely distributed packs like Kenne too. You can go a long way with free stuff. Just be ready to get your hands dirty with audio editing. Gotta be honest, I did not expect to deal with spectral editing ever in my lifetime. Hell, you know what? I did not expect I would be literally drawing a sound wave by hand. I've had the most headache with this sound that plays when you hover over the cells. cells. If you did that fast enough, it would overlap itself a dozen times per second. I solved the issue by cutting it very short and making it gradual. Hey, it works. I didn't know about audio pooling back then. Even afterwards, I thought it was too annoying, so I replaced it with this bottle jug sound. And then I changed it again to this, because I could not get rid of the some kind of weird wobbling sound from the jug audio. Yeah. Anyway, I did not have trouble with other sounds. It just took some time to pick them out. In order for the logic of the game to work and not fall apart, I made a point of building a clear hierarchy of control between the elements on the board, just like we have in real life. Except this game doesn't run on patriarchy, but rather on the opposite. Each cell, be it a box or a slab, receives data from its direct managing script, the mother. I needed to have a skeleton, an array of positions that exist unchanged in the space, which I have called sockets. During the game, cells may shift their positions, swap their axes. Sockets are there to act as geographical anchors for the real position any cell was assigned. The next tier manager, called grandmother, governs interactions between the mother of cells and the mother of sockets. Then, the highest level, the matriarch, handles and passes data between both grandmothers, synchronizes cells in 3D and 2D view, gets information from the calculators, and so on. There aren't too many things I take pride in. This system is one of them. And I don't care how stupid, ineffective, or unoptimized you think it is. It is mine. I came up with it without any tutorials. Would I have saved myself some time if I did follow along some tutorial? Yeah, I probably would have. My initial idea was to not only make a regular Sudoku game, but invent some alternative variations that could only work in 3 dimensions. These would be something like a Sudoku, but not quite. A not Sudoku, a shit Sudoku, a shit. Any reasonable and sane person would probably start building the prototype with the basic, default Sudoku game mode. Good thing I never put much worth into reason or sanity. I did, however, at least in some sense, consider myself to be a smart person. To keep doing so became an uphill battle after I've spent several days trying to shoehorn this piece of shit non-existent game mode in, and failed. Failed miserably. Failed like Icarus flying too close to the radioactive sun on his stupid wax wings. So I just sat there and put numbers in manually in my board, trying to come up with rules for this doomed mode. Of course, the game should generate boards automatically due to some algorithm, but that came much later in development. For proper testing, I've had 2 boards, edit board and game board. The game generates a solved Sudoku board in the hidden edit board, which is governed by an edit calculator. That is a script that contains all methods of generating and removing cells from the board. You see this button in the middle that's missing in the build uploaded to itch.io. This was my developer button, unavailable to mere mortals. You could click it and manually input or adjust the edit board. I used it extensively during testing. The actual game board does not create numbers. It merely checks what you're trying to input with the edit board. Suffice to say, the game board would break if the edit board wasn't filled to the full. It had its own game calculator, which had a lot less methods and mostly handled hint placement and removal logic, as well as undos and machine solvers. When I saw examples or tutorials for a Sudoku game online, they usually calculated the viability of the input number on the fly, as in, when you try to put in the number, the game checks if that cell can contain that number. That's not what I did. My edit calculator generated the edit board as soon as the game began, and then my game calculator checked any number I tried to put into the game board against the edit board. It helped to offload the logic from runtime and put it all into the beginning of the game, when the board must be generated in accordance with Sudoku rules. As you are solving a Sudoku puzzle on paper, you must use your filthy meat hands to make these small hint notches in your cells, to keep track of which numbers are excluded from any cell. In a digital Sudoku game, that's usually handled for you. For convenience, reconstructing this behavior isn't as trivial as one may think. Question: how do you teach computer to keep track of which numbers can be put into any given cell? How do you deactivate cell hints as you fill the board? So how did I do it? Let's say each cell belongs to a line. In each line there can be no more than one instance of this number. When you put in a number into a cell, every one of its neighbors should get locked. They should exclude this number from the pool of possible solutions to this cell. So how about this? When you put a number into a cell within a line, it sends a signal to every cell in this line, including itself, that activates some variable and forbids this number. If you try to put the same number in another cell in this line, it will say, hold on, if you remove this number, the same operation happens in reverse. Each cell in the line gets the line lock lifted for this number. Now multiply this by 3 for 3 dimensions. Each cell belongs to 3 lines, 3 rooms. Even one lock is enough to forbid the number in this cell. In order to unforbid the number, you have to remove all the locks. Alright, but how does this actually function in the code? Well, have you ever heard of byte flags? My implementation works with bytes. I stumbled upon this approach in some forbidden corners of the internet. Now, after all this time, I am a bit fuzzy on the specifics. It requires some unintuitive setup, but when it's done, it works like a clock made of cakes. Precise and oh so sweet. I think this may be what allowed me to succeed with my board generators and solvers down the line. Speaking of which, because of the nature of 4x4 Sudoku and extending that 4x4x4 Sudoku, there aren't that many unique board patterns. I think it's 288 for a 4x4 Sudoku. In 3D this number might technically be the same, or lower because of how tightly the data is tied in 3 dimensions. That would not be the case in 9x9x9 Sudoku. All of that is to say, 4x4x4 Sudoku isn't too difficult to solve. You can brute force it in around 2 minutes, as I have proved right here. As a result, it's really no problem to generate a full, filled Sudoku board. Start with a 2x2 room, iterate randomly through numbers 1, 2, 3, 4, fill the remaining cells according to Sudoku rules. Do that for every plane. Randomize where you can. Nothing difficult about that. Right, now you have a full functioning board of numbers. Good job. No, really, well done. Right, I'm sorry. How do you make a game out of it? You could say, well, let's go back from full. Start removing numbers one by one and each time run the solver forward to make sure the board is solvable in a deterministic way. After enough iterations, it should stumble upon the lowest number of cells with which the board is still solvable. You could say that, but it doesn't really mean much. Because guess what? That's a lot of calculations. I'm talking a whole shitload. And remember, this is to generate a playable Sudoku board, which must happen when the player presses start in an instant, or at least in a second. You can't tell people, oh hey, please wait while we generate a board for you. You have to solve this issue right here and now, without delay. Yeah, not so smart now, eh? I'm sorry, I'm not aiming this at you. I'm recognizing my past self. You hear me, dipshit? Randomly brute forcing the generator on solver does not seem like such a good idea now, does it? I tried it. Be my guest, look at it. Maybe I've missed something in the algorithm, but I doubt it. I think it's just doomed to loop over and over for a millennia and never go below 21 numbers on the board. When I went online to see how people solve this issue, I found out that usually they outsource the board generation. They either load pre-made Sudoku boards or create a separate software that hangs around on a server and generates valid playable boards to then pass them into the main game. That's how difficult the problem actually was. I wasn't ready for this, goddammit. I came here to make a game in 2 weeks and be done with it. What the fuck? I can't even make a stupid Sudoku game without running into some weird programming hell bottleneck. How pathetic is that? God. Okay, how about we go from the opposite end? We try to determine the minimum amount of cells needed to solve the 4x4x4 board beforehand, and then we run the generator from this minimum number until we get a proper board. If we can manage that, we can get board with lower difficulty by just allowing the machine to solve some cells instead of the player. How do we do that? Well, you could put X numbers in random cells and run the solver until it can generate a good board. But I think you'll agree with the logical assumption that this won't work fast enough. If at all. Alright, what's the other option? Hear this. What if we try to fill a board manually from the lowest possible number of cells, see which starting pattern results in a proper board, and then stare at the results and use our monkey pattern recognition brains to determine attributes and rules for coming up with a proper solvable board. What the fuck did I just say? Did that shit really come out of my mouth? That is horrible. Horrible idea. It's insane. So there I was, staring at these boards, noting down any rules or patterns I noticed, and then going back to Unity to test them out. It was slow, it made my eyes hurt, it made my brain hurt, it wasn't very effective, and it should have landed me in a local asylum. But it fucking worked. Don't you ever doubt me again. I've actually developed a set of rules required to place the initial 4 numbers in such a way that the rest of the board can be solved without cheating in a deterministic way. I've called it Tardy Fool Across the River, or Tardy Landlubber. Enough time had passed that I don't understand what's happening here. Let me take a closer look. The algorithm should be in the edit calculator script. That's the one that generates the valid Sudoku board to be solved. Here it is, Tardy Landlubber. It's travelers, we get the operating plane, I take neighbors from the treasure mark, what? AJP, TP, OPPP, that's adjacent plane, opposite plane, and oh fuck me. No, this is unreadable. This is what happens when you use abbreviations in your method names, devlog.
Also, don't use acronyms or abbreviations. Those might seem clear right now, but in a few weeks you might not remember what they mean.
I don't know. Wait, why is it grayed out? I'm using Grider here for scripting, and it colors any method that isn't used anywhere as gray. But why is it not used? What the hell? How? Blind? Blind for generator? I'm using the blind for? Okay, you can disregard the last few minutes of my yapping. Turns out I am using a random brute force generator. Just so you understand, this generator takes 4 planes and puts 1 number in each plane randomly. Then it tries to solve the board, and if it succeeds, it sends the board to the game. You may not have heard me correctly. It's random. It iterates through random 4-cell placements until it succeeds. How is it even working? Well, quite well actually. You can see it here. Hell, you can go play it on itch.io. It works, and it iterates through random patterns fast enough that you don't notice it working as you launch the game. That means that this solver algorithm I've put up is so efficient, I can run it several times in 1 frame and just brute force my way into a legitimate 4x4x4 Sudoku board. Wow, I mean, look at it. He doesn't even check if these numbers are occupying 1 line or 1 room. There are no checks here. It just randomly iterates through 16 cells in a plane, does it 4 times, and then checks the board for solvability. I'm baffled. I'm honestly baffled. So I'm not faking board generation. It's as real as it gets. You get 4 initial numbers, the minimum required amount for the board to be solvable, and you get them completely randomly through sheer brute force. I wonder if I can do this for 9x9x9 board. Probably not. But what if it's... oh god, what if it's doable? Hold me back, fellas, I'm getting ideas again. Oh no, I'm getting ideas again. Well, I be damned. I've kinda buried the idea of making a 9-sided board just because of how difficult the board generation would be. Now, maybe it's not that impossible. Who knows? In any case, that's all there is to say. I built my own flag system, my own solver, and it worked even better than I remember it. Maybe someone could use this approach if they ever sit down to actually make a 3D Sudoku. And if you're a particular kind of insane, even a 4-dimensional version as well. I hope this was an interesting journey to follow. It took way longer than it should have, and it also took a shitload of time to edit this video. I've learned a bunch of stuff I've never even heard about, like hash sets or byte flags. This project has really shown how much more complex a seemingly simple game can be when you actually sit down to make it yourself. This was supposed to be a small adventure, Morty, in and out in a week or two. It turned into a downward spiral into madness, and that's how I like it.
Oh, what a day! What a lovely day!
It makes my blood boil, it makes my brain race. I see solutions at night, I dream about them in my sleep. This is why I fucking do this. But I don't want to be stuck doing a goddamn Sudoku game. Unless I know for certain it can work. Maybe sometime down the line when I can get at least some profit from my endeavors. We shall see. For now, I leave you with this. The difficulty is not the problem. The perception of difficulty is.